can't undo that x in the exponent. You know, if it's a equals b squared, well, I can just take the square root of both sides and solve for b. But there's no like square root of x. I don't take the x root of something to solve for b. I can't undo the x in any way that we know of at this point. And this is why logs came into place. So if you would just remember that this number that's beneath the exponent is always called the base. When you do a log, the number down here is the base. Okay? And the way I remember it, to convert this to a logarithmic equation, I always know when I get done with the log, these two will never be by each other. That's just in my mind. So if I can remember the base, this is the base, so that goes here. These two will never be by each other, so this is always this, and that's that. Okay. Sometimes you'll see an arrow, b to the a equals x. Log of b to the a of a equals x. But the way I remember it is, write my base down. Remember that this will never be the same. It won't be b to the x here. So those two just switch. Okay. So when we deal with logs, the two most common bases with logs are base 10 and base e. Okay, and a lot of times when you see log base 10, they don't write the base. So if it's log, if I were to write log 3, the 10 is implied. Okay, because that's called the common log. So if there's no base written, you assume it's 10. Okay? Also, if I write log base e of 3, log base e, the other way that we write log base e is natural log. So you can rewrite, when you see a natural log, you could rewrite it as log base e, so in your mind you remember it's always a base e that goes with the natural log. All right. Couple of things then with logs, adding logs, subtracting logs, exponentiating logs. Okay? Because we're talking about the inverse of exponents, when we multiply two exponents, we add them. So when we add two logs of the same base, we multiply them. It's the inverse operation. Okay, so when I look at log base b of x plus log base b of y, just do that. I can condense this, because they have the same base, to the log base b of x times y. Because if I multiply the exponents, I add them. If I'm going to add the logs with the same base, I multiply those components. So what do you think you do with subtraction? Divide. So log base b of x minus log base b of y is equal to log base b of x over y. Okay, and then if I have, what's the third? Exponentiation. Let's see, my computer is so slow today. Come on, go up. Keep going up. If I have log base b of x to an exponent, that exponent can come around to the front. As an example, let's do log base 3 of 2 cubed. This is the same as 3 log base 3 of 2. Okay, and I don't know if you remember, but I'm trying to think of the phrase we call it. change of base formula. Getting it to base 10 is how you will operate your calculator. Right? Calculator doesn't have a base 3 or base 2. When you hit log in the calculator, it's the common log, it's base 10. So in order to get this, so I could actually compute this number, I change my base to log base 10 of 2 divided by log base 10 of 3. It's the log of this divided by the log of this. Then I can put it in my calculator and actually figure out what log base 3 of 2 is. Okay, so exponentiation, if it's got an exponent, you bring it down. If it's not a common log, you can make it a common log using the change of base formula. Okay, all of these rules are in the properties of logarithms videos that are in this section. So if you haven't watched them, to refresh yourself, that would be helpful. He'll go through and do some actual examples with these quotient properties. Then there's some more examples actually in the book using logs and condensing and expanding logarithms using the multiplication and division rules for logs. Okay, exponentiation rules, bringing that down. Some other important things to know or remember are these 4 bullets here in the book. The first one says log base b of 1 is equal to 0. No matter what the base is, okay, and let's see why. Log base b of 1 equals, let's call it x. Okay, how could I put this as an exponent? Convert this back to an exponent. Well, what is that exponent that no matter what it is? Yeah. So that's why log base anything of 1 will always be 0. Log base 10 of 1, log base 3 of 1, doesn't matter what it is, always 0. Okay. Next rule, log base b of b is equal to 1. So let's do 10 of 10. Well, 10 to the x equals 10. What's x? 1. So if this is the same as this, the answer is always 1. Third one, log base b of b to the x equals x. Well, what did we already say? We bring this down, so it's x, log base b of b equals x. Sorry, this is 1. 1 times x is just x. So whatever this exponent is, if these two are the same, the answer will always just be that number. If I do log base 3 of 3 squared, it's just 2. Okay, and then the fourth rule, b raised to the log base b of x is equal to x. I'm trying to think the best way to explain this. I think if I take the log of both sides, this becomes log base b of x. This comes to the front, so I have log base b of x times 1, right, equals log base b of x. So I just proved that b raised to log base b of x is always x. So if I had 3 raised to the log base 3 of x, I know, let's do this, of 2, it's just equal to 2. Okay, those 4 rules come in handy. There could even be a question on the ACT. There's at least one log question on the ACT. And a lot of them, let's see if I can come up with one. What do you think here, without even having to use change of base? The key to these is seeing if you can find a number that will match this number. Because we know log base 3 of 3 is just 1. So if I could rewrite 27 with the same base as 3, I can see right away that's just 3. Right? Because the log base b of b is just the number that it's raised to. This number is 3. This goes away. So the answer is 3. So if you can rearrange and rewrite these numbers with the same base, the answer will just jump out at you. A lot of times you see a problem like this and you're like, I don't know what to do. But just think, if I could match this base with any number, I just know the exponent's the answer then. ACT likes to put questions like that on there. Anyway, I think this review that we do in this section will really help, especially as we're getting closer to the ACT, to get a couple questions. Okay. On that note, we only have a few weeks left. How do you feel the review with Baylor did with you on as far as reviewing your algebra and geometry skills? Are you feeling like a little more refreshed, or do you want me to start just pulling one ACT question at the beginning of every period? We just do together to refresh.
I think we should do that.
You want to do that? So I've got lots of sample tests. So
I'm when I go do like the tests and stuff of it, and then I go see like the ones I miss, I like go do them, and then if I just have like an extra minute, like
right.
I know how to do it. But, like it's not that I don't know how to do it; it's just that I don't think fast enough to
right.
skip half of the steps.
Well, and if you're worried about finishing, it's kind of like the advice that I gave Jake on reading, because reading was something he never could finish.
Make sure you get the first.
Yeah, I mean, every question on the ACT on math is worth the same value. The hard ones and the easy ones. I mean, if you can just make sure you get the first half perfect, all the ones you know how to do, and just work your way through, even if you have 5 or 6 left and time's out and you just bubble, you'll be better off than trying to push yourself to finish in time and then going fast on the ones that you know you could do. You know what I mean? So ultimately, you're going to get the best score if you can finish it. But finish it at your pace,
And it's weird because like both times I've taken the ACT, like I've only not gotten to like 5.
Mm-hmm.
But like when I'm doing these practice ones, I'm like doing really bad at it.
Yeah.
Like at like finishing the time.
Well, the 21st is really going to help you too.
Yeah.
We're going to do, I know it's not fun, but we're going to do the full-blown, that way you guys get that first test jitters out of your system. So when you really take it, you'll know what to expect, and it's not going to be having to fight the test protocol so much as just being able to do the work, So, well, why don't Monday we'll just start, I'll just pull a test up, and I'll just start on number 1. And if they're really easy, we'll do a couple together. Just take the first 10 minutes maybe of every class just to refresh you on some of that early skill that you haven't seen in a while. And then can carry forward with the chapter, because whatever we're doing in the chapter will help you too. Okay. That is it.